Hey folks, we're going to continue on with lesson 5.2. The first bit is the sign of x and different effects. If we put a number out front like 3, sign of x, we all know that that affects the amplitude. If you change that to a negative, it would flip it from the starting point. The period in this case, we talked about it being 2 pi over omega. Omega is the coefficient of x, or whatever your angle is in there. So in this case, it's just 2 pi over 1. And you can see that this completes, both of these graphs complete one full cycle after 2 pi radians, okay? So then what happens when we take that negative 3 sine x and we bump up maybe by chance like a plus 5. So there's your midline now. Your midline goes up to this line 5, y equals 5. And from there you start, so you just basically shift this blue graph from 0 to the midline of being centered around. So if I were to draw this whole line across here, the line y equals 5, that's your midline. So we discovered that. Okay, well, what if now I take, and let's just start with a simple graph. If I take this as sine x and I add a 2 to it, um, okay, so that 2 seems to take the sine graph and shifts it over a little bit. Okay. What if we add in a pi in there? Let's see. Pi is below there. Huh. It shifts the whole graph over. So sine of 2 pi, it actually looks the same, doesn't it? So that's really interesting. What if we just do pi? So I should probably just put the original graph too so we can see. Huh. It looks like it flipped it, but it didn't actually flip it. So sine x, the blue or the purple, is the original graph. But this pi seems to take this graph and move it to the right or to the left. Let's just do pi divided by 2. So that seemed to move it over. So the red is the graph that we're shifting from the original sine x graph. So you can play around with this. This is called the phase shift. So you can see that these two functions, they're out of sync, but they still have the same amplitude. And even if I put like a 2 in front, see how it affects? It's the same amplitude in either case, but it shifts this graph over so many units to the right or to the left. Okay, in this case, it's actually going to shift it over to the left, believe it or not. And that has to do with functions and transformations. If you add something on the inside of the function, it actually is a horizontal shift to the left. If you're subtracting something, on the inside of a function, it's a horizontal shift to the right. So I'll tell you how to find that specifically. Let's just say I want to change the period. Remember, the period is 2 pi over the coefficient. So if I made this coefficient 4, let's just say. So that would be 2 pi over 4, which would be pi over 2 radians. And then we have to keep it consistent. So you get the same graph, right? But we have 2 pi over 4, which is pi over 2 radians that it completes one cycle. So the purple, it's going to finish in pi over 2 radians from 0 to pi over 2. Now the same thing goes with this. It starts here on this graph, which let's take that off. So at negative pi over 8 radians, and it ends here. We'll take this one off at 3 pi over 8 radians. So let's remember that function and we'll go and I'll show you how to actually find the phase shift. So from the previous lesson in 5.2a, we found that the amplitude is equal to 2 and that the period is 2 pi over omega, and in this case you can see that omega is 4, which simplifies to pi over 2. So we found the period and we found that this is 2. Okay, the way to find the phase shift is to think about the original sine graph here. So the original sine graph, I know that it completes one full cycle in 2 pi radians. So basically the idea for this is that if I set this equal to 0, that's where I start, and then I'm going to set it equal, I finish my cycle or my period or one full um, go around the block at 2 pi radians. If I solve this, I get that 4x is equal to negative pi over 2. X is equal to negative pi over 8. If I solve this one, I subtract the pi over 2 from both sides. That's 4x is equal to, that would give me 1.5 pi, or we could just say 3 halves pi, 3 pi over 2. And then if I divide that, that's x is equal to 3 pi over 8 radians. So this is where we start with our cycle and our graph, and this is where we end for one full, um, basically, I always think cycle because this is all circular, it's periodic. So if I were to sketch a graph of this, and we kind of already know what it looks like, we know that we're going to start at negative pi over 8. And this is the hardest part to graph. You start at negative pi over 8, and you know you're going to end at 3 pi over 8. So staying consistent with this, you've got 1, 2, so 1 pi over 8. This is 0. So then you have 1 pi over 8, 2 pi over 8, 3 pi over 8. That's where we're going to end. But, and so that's 1, 2, 3, 4. So that actually breaks up this graph, which is what I wanted it to, into 4 equal parts, like that. And remember how we graphed sine before? We said, okay, we start at 0 here, and we end at 0 at 3 pi over 8 after the period. We know that the period is pi over 2, so does that make sense? Well, if you think about the distance, you've got this is pi over 8 units, right? So you have pi over 8 plus another 3 pi over 8. That should add up to pi over 2, which is 4 pi over 8, which is pi over 2 radians. So yes, that is the period. From this point to this point, it's pi over 2. And then basically, it's nice to know that these, because this would be 1, 0, this is 1 pi over 8, so we could say that this is pi over 8, and this is 2 pi over 8, which is pi over 4. So it's nice to know basically the quarters of your graph, your sine and cosine graph, but that's basically it. You don't have to get the stuff in between because I know that I start at negative pi over 8, that's my phase shift. I end at 3 pi over 8. I halfway between with sine, I am at 0 once again. Halfway between negative pi over 8 and pi over 8, I am above unless it happens to be a negative out here, but it's positive 2. So I'm 2 units because of my amplitude. So this point right here is at 0, 2. So I've got this first part of my graph, right? And same goes now halfway between this pi over 8 and 3 pi over 8. I know I am 2 units in this case below. So here are my 2 units, negative 2 below, and I can draw this graph. So I think I only expect you to be able to draw without a calculator the sine and cosine curves, finding the phase shift and finding the amplitude and the period. But really there are one, two, three, four, I guess 5 important points that you need to draw. So the zeros in sine, it has the 3 kind of zeros, or if it's a shift up or down, you would be wherever the midline is, that's where your center is. And then the point that's above it and the point that's below it. And then you could continue that on because you've got 4 pi over 8, which is pi over 2, uh, 5 pi over 8. See, I'm breaking it up. And then 6 pi over 8, which is 3 pi over 2, if I'm doing my math correctly, and 7 pi over 8. So I go 1, 2, 3, 4 more. So if I wanted to continue this, I end here halfway between 5 pi over 6, I'm there, and then I'm going to go up, and I'm going to go down, and I just continue to draw my curve. Okay, and you can always verify this with the graph. So let's look again at the graph of this. So here you go. We've graphed, I typed this into Desmos graphing and I started at negative pi over 8 and then I ended at 3 pi over 8. And if you look at that, halfway that's pi over 8. Okay, so that does confirm how we graphed this. Down here that would be pi over 4 negative 2. Up here it should be 0, 2. And then you could continue the cycle. So I do want you to get specific period, find the period, the phase shift, and the amplitude and the midline of each graph. And with sine and cosine, I want you to be able to graph it without the aid of a calculator. But for tangent, cosecant, and secant, you can find the period, phase shift, and amplitude, but then you can use the graph to assist you in when graphing. So this is from the book, and it basically is what we did in this example. We had the 4x plus pi over 2, and we found that it was negative pi over 8. This is actually the phase shift. I'm going to do PS for phase shift. And then when we solved this one, 4x plus pi over 2, and set it equal to 2 pi, we solved and found that it was 3 pi over 8. 3 pi over 8 is basically pi over 8 plus the period. In this case, we know that the period is pi over, what is the period again? The period is 2 pi over 8, which is pi over 4. So if you break this number up, you end up getting what they're trying to show is that you get the period plus the phase shift. So you're just adding on your period to the phase shift, and that's where you end up. That's your final. Okay, and that's what we did. We ended up at 3 pi over 8. So the quick way to do this, just the phase shift. Phase shift is always just equal to, in this case, we have omega, which is here. So we've got our omega, and this is phi. Okay, so it's just going to be a simple, basically, phi over omega. So if you didn't want to set each of this equal to 0 and then also equal to 2 pi, you could just solve it's the constant inside the function pi over 2 over omega, which is 4. And if I simplify that, that is pi over 8. Uh, And the formula is actually negative because that doesn't make sense that we have positive pi over 8. We were talking about that. So you do put a negative out front and it's negative pi over 8. And I always remember that if you forget this, that it's negative phi over omega, just set the inside function for x plus pi over 2 equal to 0 because we know that's where the sine graph starts. Same with cosine. And you solve that. And don't forget your x, of course. That's not a pi. So x equals your negative pi over 8. So if you ever forget the formula, just set this inside stuff equal to 0 and you solve for x and you'll find what your phase shift is. So now we know how to find the phase shift, the period, the amplitude, and move things around with the midline. Okay, so let's practice with this graph here. First, let's identify the period and we'll identify the amplitude. Remember, and this is in your book, you got these two formulas. So the amplitude is the absolute value of the coefficient of the sine or the cosine. So we're looking at cosine. And then the period is 2 pi over omega, same, same, and same, and same here. It just is a matter of where you start. So we know then that the amplitude is 20. The period is, and this is omega, so the period is 2 pi over pi, and that's equal to 2. Now note, here is our, we're going from negative 1 to 3. If I give you something like from negative 1 to 3 without any pi's involved, well, that kind of tells you maybe that your period should be just without pi, which is kind of nice when you set up basically your scale. And so we'll do that in a second. And then the phase shift, we can say that the phase shift, PS, is phi over omega. So phi is Oh, and it's also negative, so of this form. I guess in this book they're not showing that because it has to be of this form, the minus. So in the other formula, if it's not in the minus, then you have to, and I guess that's kind of what I was using. So you can use positive, but it has to be a minus sign here. Okay, so the phase shift in this case is just pi over 2 over pi. And so if we simplify this, that's pi over 1, and you flip it, it's basically pi over 2 times 1 over pi. Pi's cancel out, so the phase shift is 1 half. Okay? Now, if it happens to be a minus, believe it or not, on the inside of your function, a minus something, then it's going to be a shift to the right. So we're going to shift it to the right. So you can just check your signs. Okay? And if, for instance, let's just do a simple example on the side. If you had, for instance, cosine of pi x plus pi over 2, I know that because of this plus, it's actually going to be a left phase shift. I'm going to shift left, a left shift. Okay, so it should, your result, like we did before from our example, your result should be a shift to the left and it's negative. So in this case, I would rewrite this as cosine of pi over x minus negative pi over 2 so that I could get it into the form of this right here. So it has to have a minus here. So if you want to think about it that way, that would probably be the best. So we can stick with this book's format. Okay, so we know our phase shift. And just to show you, you don't even really need graph paper, but graph paper is kind of nice. But so what I do is I think about, okay, I've got my phase shift of 1 half and my period is 2. So, and my amplitude is 20. Well, boom, there's 20 and there's negative 20. That's nice. Okay, my phase shift is 1 and my period is 2. So I need to break this up into basically thinking about your period, breaking up your period into 4 equal slices. So I'm interested in doing this in halves. Okay, so if I think about that, here is 1 half. And where are we going from negative 1? So here's 1 half, here's negative 1 half, here's negative 1, here is 1, here is 3 halves or 1 1/2, here is 2. I still have a little more to go. So 2 1/2 or 5 halves, and then here is 3. Okay, and then I start with my phase shift. I start at that spot. And since I'm dealing with cosine, I don't start on the line. I actually start, in this case, because it's positive 20, I'm going to be above. Remember, if it was negative 20, you would start down here. So with cosine, you start above, and then after a full period, which is going to land me at 1 1/2. So remember, this is 1 1/2. So a full period, wait, actually it's at 2 1/2 is right here, is going to land me right there at 2 1/2 because 1 1/2 plus 2, my period, lands me at 2 1/2. And then I can look at halfway. Well, here's 1, here's 1, here's halfway. So this is halfway in between, and I'm going to end up, this is just the nature of cosine, halfway in between you're down below. You're the lowest, at the lowest spot on cosine. Halfway in between that, that's where you have your zeros or where it intersects the midline. So remember, the cosine graph takes on this kind of shape, like so. We have to keep going with this, so we're going to continue this pattern up until 3, because that's what the problem was asking. So we're going to stop there. We can stop there, but you know it continues on. And then if you see the pattern, remember, you just go, okay, well, the next mark, it's down at a 0. So I continue that. The next mark, I'm down below here at negative 20. So there's this. And then I'm going back up here. And that's where I finish my cycle. Remember, it continues on. Okay, but this is basically what we're graphing from here. You can stop to there because that's all that we're defining the function for. Now imagine if you added like a 3 to this function. So everything would be bumped up 3 units. Let's use a completely different color here. So that would mean that this graph would be 3 units above. I have this like line y equals 3, right? So then that means that this max is going to be 3 units up here. So instead of this point being 1 half comma 20, it would be 1 half 23. So everything's bumped up. Okay, so this is just a little portion of it, but that's what your graph looks like. Um, it doesn't affect where it lands, so it starts back at the midline. It's not a 0 in this case, but it's the center, so it goes back to its center, and then it ends up, and that would be, if it's bumped up, it's going to be at negative 17 here. So then you're down here. So this point right here is 3 halves and negative 17. So that kind of picture in your mind. So that would be like a plus 3 here. Okay, so once again, y equals 3 is your midline. Let's do one more example and then I'll just show you a little more with graphing. These are the important features that I want. I want the maximum and the minimums on your graph. You don't have to label them all, but labeling a couple would be nice. So this is negative 1 half, negative 20, and maybe this point 0, 0, this point here 1, 0, another min, another max, just a couple, so I get the picture, and just make sure that your scale is correct. Okay, and to be aware that that's what is on the graph, that it corresponds. So for sine and cosine, I want you to graph by hand and without a calculator. With any others, tangent, cosecant, secant, and cotangent, you can use a graphing tool to help you. So with cosecant, if we're going to use this function, we're going to use this. I also don't expect you to memorize these. You can just learn sine and cosine and you'll be set. Basically, they're all the same except for tangent and cotangent. And the other thing is undefined amplitude, I guess, for tangent, cosecant, secant, and cotangent, because remember they have asymptotes. And so, like with cosecant and secant, they kind of take on this shape where they're above and below. Okay, so with this, we can at least find the period. So in this case, it's 2 pi over omega again, which in this it's 2. So we know that the period is equal to pi. And we can also find the phase shift. And since it's of this form, the minus right there, all we have to do is phi, which is negative 1, or just 1, over omega, and omega is 2. So the phase shift is 1 half. Now, if we were to just graph this, I'm going to show you on your calculator because, like, for instance, on an exam, you would have to just use this. So we've got 2, and then cosecant is 1 over sine. So we can just do the division sign, sine of 2x minus 1. And if I graph that, okay, so we said that the period is pi and the shift over is 1 half. And how do you even see that? Well, it's kind of a challenging thing, especially on this, and you can't really even find points. If you wanted to, you could trace along. So something like this to find the maximum and guesstimate, but it just gets really challenging. So if you can just find, in this case, if you show me for your homework the pi and then the 1 half and then sketch a graph, and honestly after looking at that I think that Desmos would be the best way to do it. So if we were to graph here, and they even just let you do cosecant, so if you graph this you can get some nicer points here, here, to estimate and to draw your graph. And the book doesn't specify the interval that they want you to graph, but they just want you to graph um, uh, one cycle of the function either by hand. So one cycle of the function would actually just be with a phase shift in this case of 1/2 and a period of um, pi, you're shifting everything over 1/2 units. So here you go. You can graph this portion and this portion, and that would be enough. But it's okay to graph more than that if you want to. But just to be aware that it's here, and that is basically one full cycle. And going back to this graph on the graphing calculator, you can actually find out your vertical asymptotes by looking at the table. So what I did here was I went to a table set up. So that's second and then table. And I wanted to start at 1/2 because I knew that that was my phase shift. So change that. And then this next value, I actually did pi over 4 because I know I'm breaking up pi into 4 equal parts. So I wanted to move it every pi over 4 units. So I did pi over 4 and then make sure that the independent and the dependent variable are being, you're asking, or you're doing auto. The calculator does all the work. So then you go into your table, which is second table, and you can see that there's an error at the 1/2, at the 2.07, and so on. So these are your vertical asymptotes.